In this video, I'd like to go over graphing sine and cosine functions, and specifically I'm going to graph a sine function with an amplitude change and a period change. So before I go into that, when you're graphing sine and cosine functions, it's good to first remember that general shape that they each have. A sine starts at 0, 0, and then it goes up, down, back to the middle again, and it finishes that whole cycle in 2 pi. And I might even want to keep track of all of these points in between. These are considered the 5 key values whenever you graph a sine or cosine function. And those are essentially the quadrantal angles. And if you don't remember which one is the sine versus the cosine, just think that this goes back to the reason that this has the shape is because sine of 0 radians is 0. And that's why we have that point there. The sine of pi over 2 is 1. And that gives us this point right up here. And then if I keep going, the sine of pi is equal to 0, and that goes back to this 0 point. The cosine is similar, because if we graph both of these, whether we're graphing sine or cosine, if you zoomed out and looked at the whole thing, it's just going to look like this. It's just a matter of kind of where it's starting. And so for the cosine, it starts at the maximum. And cosine looks kind of like a U. Same thing, it goes from 0 and it ends at 2 pi here. The reason it's starting up is because if you do cosine of 0, the answer is 1. And that's why it starts up as opposed to starting at 0. Let's say we want to graph the function -5 sine pi over 4x. The amplitude is 5. There's a negative in front, but whenever we talk about amplitude, we're just trying to say how far it stretches from the center, and so the answer would just be a 5. But the negative does tell us that the graph is going to flip along the x-axis. So a couple of things here that tells us our final graph. 1, instead of going between 1 and -1 as the max and min, it's going to go between 5 and -5 as the max and min. And a lot of graphing sine and cosine functions is really rescaling the y-axis and rescaling the x-axis. So now we've rescaled the y-axis to go between -5 and 5. It's going to start at 0, but instead of going up first, the negative means that it goes down first. And typically it would end at 2 pi, and this would be the graph for -5 sine of x. But we do have a period change, so that means we're going to need to rescale the x-axis as well. So we can figure out the new period. It's going to be 2 pi divided by that value multiplied by x, which is pi over 4. Dividing by a fraction is the same thing as multiplying by the reciprocal. Now that means when I go ahead and graph it, I'm just going to draw another quick sketch here between -5 and 5, and now it's going to go from 0 to 8 instead of 2 pi. Okay, so this gives us a general idea of the graph. I will say to really make a good graph of a sine or cosine function, you do want to find all the 5 key values. So that's what I'm going to do as the last step here before I make the final graph. So 5 key values. So originally they're 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the same way we found the new period, in this case by dividing by pi over 4, we can do the same thing to each one of these values to figure out the new value. And since in each case we're dividing by a fraction, I would change it to the reciprocal and do multiplication. First one's going to stay at 0. 0 divided by anything is still 0. And next one for pi over 2, I'm going to multiply by the reciprocal, which is 4 over pi. And the last one we've already figured out, which was 8. So these are the new 5 key values. So I'm going to try to draw a more exact sketch of our function. So the x-axis will now be 0, 2, 4, 6, and 8. Plotting the points, we start with the point 0, 0. Then the next point on our graph is actually 2, negative 5. The next point is 4, 0, 6, positive 5, and finally 8, 0. So these are the key values. We've plotted the points. So it looks like a straight line, but we know that the graph is going to be curved. And it should look something like this. And this would be the final graph for negative 5 sine of pi over 4x.